Right? Okay, so let's start with today's class. In the last class, we had done two programs, right? So we'll see about how to use the software to execute these programs. Okay, right? So please have the program that we had already done in the last class. Okay. Right. Yeah. Can you see the screen? Hello.
Yes, sir.
Yes. Okay. All right. Fine. Okay. So now we have done in the last class, if you remember, the first program that we wrote was for this particular diagram, right? It was a stepped bar. Okay. Having first step 20 mm diameter, length is 20 mm. Then second step is 40 mm diameter, then whose length is 25 mm. Then finally the third step is for 60 mm diameter and 30 mm length. So total length is 75. Okay, right? Okay, so we had written the program for this problem. So let us see how to execute it onto the software. So for this, what is the condition? Diagram will be given, okay, and we have to write the program and execute the program. So how will the question be like? So write a manual part program for the part shown below. Okay, they may say that using SeeNC Turn or not. This may not be there generally. They'll only say write manual part program, okay, for the given diagram and show us the simulation, okay, right? So that is how usually it will be asked, right? Okay, so as I told you, here we have uh, four in the CADM software. We have four different modules. Uh, I hope you can see the screen a little bit better. Not, I hope it's not too blur. So one is over here, the CNC mill. Okay, this icon over here on the second row, second column. Can you see that? Hello? Hello?
Yes, sir.
Yes. Okay. So CNC mill, CNC turn. Then you have over here in the first column below caps mill, caps turn. Okay. So totally four modules, four different, four softwares are there. Okay. So here we have to choose the correct one. So we have to write the program first thing and execute it. Second thing, it is using a lathe machine, CNC lathe machine. Okay. So for that, you have to go to CNC Turn. Okay. Right. So this software is for writing the program and showing the simulation. Right. So yes. So we'll go here. Double click on this icon. Right. So this will be the initial screen when it comes up. Okay. Right. So before going to here, okay, you would have written the program in the on a sheet of paper or in your observation book. So what we tell you is that first go to open a notepad file, okay, write it down completely, write the program completely, okay, type the program completely in a notepad file and save it. Okay, please do that first. When you're doing it on the software, write it in a notepad. Okay, save that notepad file. Okay, right? And then we can copy this program and paste it onto the software, right? Okay. So, yes. Okay, so coming back to the software, right? So, yes, this is the initial screen that we'll have. So, next thing is that, okay, once you click on open folder, you will get this window, okay, or else even if you click on to the anywhere onto this background screen, you will get this window initially. So here, what we can do is that we are going to create a new part, okay, right? We are going to create a new part. Okay, we are writing the program for the very first time. We have not saved the program at all. So go to create part first. Okay, select this option. Okay, right, open an existing part. All right, if at all, if it is there. Okay, so since I'd already done it, I've been through that. Okay, right. Okay, so all right, so the other way is that, okay, the other way is that what you can do is go to open an existing part, use that option, right? Use this option, open an existing part. Okay, click on OK. Okay, then you get this window here, right? Click on the file that you have saved in notepad.txt format. So I have written it as program number 1. So I have given the file name as P1. Okay, select that notepad file, open that. All that program that was there in the notepad will be loaded up over here in the program editor. In the program editor. Right? Is that clear? Any doubts? Any doubts? Right? So next step. Okay, so we have just loaded the entire program that has been typed. Okay, right? Only the program should be there, no descriptions and all. Okay, no descriptions, only the program. Right, see here in this notepad, no descriptions are there. What is G21, what is G99? No, nothing I've written, only the program. Right? Even if you are using open a new part, start a new part, you can copy paste that program over here. Yeah, from notepad file to the program editor. Yes, we can do it. We can just copy and paste it. Yes. So after you pasted the program, first click on save. First click on save and save this program first. Okay, right? So then what we are going to do next step is that we have this icon over here onto the menu bar. Okay. Which is the fourth icon from here. New file, open a file, save a file. Then the fourth icon is called as the blank. Okay. When we click on this, okay, when we click on the blank, see define blank, right? When we click on this, this particular window will come up. So first, now what we have to do is that we have to give what is the billet size. We have to give the billet size. What is the raw material length? What is the diameter of the raw material? So length is over here. Okay, right? So the overall length of the finished part in the program is for 75 mm. So we'll give another 10 or 15 mm extra. Okay. Right. So then we'll give the diameter. The maximum diameter over there was how much? Was it for 60 or we have changed it? What was there in the program? Okay, I've taken it up over here. I've taken it up over here for 1 minute. 50 mm. Okay, 50 mm diameter. Right. And one more thing. Okay, and look here, I had given start Z at 2. I already explained this in the last class. Okay, we can give start Z as 0. What will happen if I give 0? What will happen if I give start Z at 2? Okay. right? So the next thing that we'll do after that, after giving the details in the blank, click on OK. We'll click on OK. Then next thing is that after define blank, the next icon, you can see a kind of machine kind of symbol. Okay, that is for select machine, right? For select machine, click on that icon. This particular window will appear. So select any machine, just give select. All the thing that we need to do here is that we are only assigning this program to which machine, that is this particular step. So click on, you can only click on select. You can just select any one of the machine and click on select. Okay. So the next thing is that before we start the simulation, we have to check if there is any error in the program. Okay. So then we are going to click on to the next icon. So here we have the error check, that is 1, 2, 3, 4, 5, sixth icon from the left side. Okay, right. So click on this tick mark symbol, which is for checking any errors present in the program. Right. So once you just click on that, immediately it will run, it will see whether if there is any error. Okay, if there are no errors, yes, we can proceed. If there is any error, then those errors will be indicated over here in the white space below that is present. Okay, so I have written the program without any errors. So thereby in the simulate, I mean, when we check for any errors, no, it doesn't show up. Okay, so I'll just, what I'll do is I'll just remove one of the uh, uh, part of the some program code. Okay, and I'll go for error check once again. Okay, just to show you what is, how it is going to appear. See, I just removed just now I just removed in the feed. Okay, what is the feed that has to be given? F is equal to F 0.2, which is there in the program. I have removed it. Okay, I'll save the program and I'll check for any errors. Right? So when I do for error check, just look here, now it appears. Line number 8, okay, no feed rate commanded. We are using G01 code. For G01 code, we should always give with feed at what speed the tool should move. We are going to give the instruction to the system, right? So line number 8, okay, that means where is it? It is over here at N30, okay. So even if you click on this particular error command, it will show that respective line where it is, where is line number 8. So maybe required changes. So I'll put back that correct value. I'll put the feed rate. Okay. I'll click on save and check for errors once again. See, now that error is gone. Right? No errors. Even if there is one single error also, we cannot go to the next step. Please remember this. For any program, there should not be even a single error. Right? Any doubts still here, or you want me to repeat anything? Hello? Yes, any doubts?
No, sir.
Right? Others? Right. Okay. So let me continue. Yeah. So after checking the error, okay. Now we have assigned what is the size of the raw material. We have incorporated the program. We have checked if there is any error. Right. Right. Okay. here what I'm just making it is that, okay, so we have just written the program, just minor modifications I'm doing it over here. That is, I'm just rearranging some of the terms, I mean the codes, okay. So here, after the tool is over, after the usage of the tool is over, the next step should always be M05, that is for the spindle to stop, okay, or else it should be that the tool should be moved to the home position, okay, and then the spindle should be stopped, right. So now just check here, just I rearranged it. So just look here, what was there previously. So I'm going to line N120, I'm going to N25, M05, M09 as spindle stop and coolant off. So I'll paste that immediately after the usage of the tool. So what is here? Tool is being used in G70, okay, and then immediately after that, spindle is being stopped. Tool has not yet been sent to home position. After the spindle is stopped only, tool is going to be sent to its home position, right? So I'll go for error check by making this modification. Now see here in the dialog box, you can see 3 errors that is being listed. Line number 26, end spindle speed programmed, okay. Then line number 15, end spindle direction programmed. So there is changes even if there is not aligned properly. I mean alignment means it should come in a proper sequence. So always after the usage of the tool should be moved back to its home position, and then after that the next step should be spindle off, okay. So I'll just replace it once again. Now if I run the error check, there is no errors because everything has been correctly put in order, okay. Okay, so the next thing is that we have to assign the tool. Which tool should I use? Okay, so if you just look over here, N105, M06, T0202, okay, which is nothing but change of tool. So we have to insert the new tool number 2. Okay, previous above that it is T0101. So 2 tools are being used. We have to assign which tool, which is tool number 1, which is tool number 2, okay. So we'll assign that. So after the error check icon, the next icon is the select tool, that is this one, this particular one, okay. Select tool, click on that icon, this particular dialog box will appear, okay. So I had already simulated it once, so thereby it is showing me already the tool, okay, right. So when you do it for the first time, it may be there, or generally it will not be there. These 2 tools will not be there, it will be only blank over here, okay. So we have to click on add tool, we have to first give the tool number 1, okay, then click on add tool. Then you have to, this particular window will appear where on top left you have tool library. So where we are going to have 2 modes, one is in inches and the other one unit in mm. So we'll go with mm, okay. So keep it in mm, that means the tool are measured, all the tool details are measured in mm, okay, right. So next is what? Okay, So next is click on external turn. We are doing turning operation onto the outer surface, right? So we have, once you click on that, we have various tools inside that, sub options, where this shank size will differ. So once shank size is 16 by 16, next one is 20 by 20, and so on. Okay. So just click on this external turn, click on shank size 16 by 16, a set of tools, which turning tools whose shank size is 16 by 16. So we have a code for the tool PCLNL 16, then again 16, H9, then the last one is R.4, right? So they, if you look at the next line, all the codes are same except the last R.8. Then you have R.2, right? So like this. Out of this, which one should we select? Okay, tool number 1 is for facing operation as well as for turning operation. So we will select PCLNL 16 by 16 H12 R8. Okay, that means radius, tool nose radius is 0.8 mm. Okay, so for this, if you want to check how the tool is going to look, or we want to make any modifications for the tool, select that particular tool, the nearest tool, click on Edit Tool Geometry. Okay, click on Edit Tool Geometry. This new window will appear. So now here onto this shank, okay, now look here, this holder width is 16 mm, okay, approach angle, if at all we want, we can change. Nose radius is 0.8, that is what is that R.8, R.2, R.4 and all. What is the nose radius? Okay, what type of tool bit are we using? Okay, right, whether we want it in diamond shape or triangular shape, which can be selected from here, right? And what is the holder length? Yes, you can see that also, right? Okay, so for how long can we cut? Cutting edge length is for up to 12 mm, which has been indicated over here, right? Okay, so we can have a look about all the details of the tool over here. If at all we want, we can make the required changes for this. So click on OK, right? So R.8 PCLNL R.8 will be used for the facing and rough turning operation. Click on OK over there. We'll come back to this particular screen only. So we are okay with this particular tool PCLNL 1616H12 R.8. Click on OK. That particular tool is being selected and it will appear in this tool configuration. Okay, right. So next we have to select another tool for T0202, which is used as the finish turning operation. So for this, the tool should be much more sharper. Okay, so here now what we'll do is enter the tool number as number 2. Okay, and then click on add tool. Yes, again we'll come back to this screen where we have the list of tools. Okay, so make sure that the units is in general mm, that is mm. Go to external turn, shank size 16 by 16 once again. A list of tools appears. Okay, so for finishing tool, what we'll do is we'll go for PDJNL 0.2. Okay. See this particular tool PDJNL 1616H11 R.2. That means 16 by 16 is this shank size, okay, the cross section, and the radius of the tool nose radius is 0.2 mm. That means it's going to be sharper. Okay. Yes. So once when you click on edit tool geometry, now just look at this nose radius. It is 0.2. Angle is going to be 55. Right? See, the nose radius is only 0.2. That means it's a very sharp tool, cutting tool. So we'll click on OK over here. Okay. Once we click on OK, we'll come back to this list of tools itself. So we are okay with the tool to be used as finish turning operation. So we'll click on OK in this particular box also. And now in this window here, which are all the tools that we have selected has been indicated. So tool number 1, what is the shank size, which is the tool ID. Then tool number 2, shank size and the ID. Okay, that is the tool number. Okay, and then click on OK over here. Right, once you click on OK, we'll come back to this main screen itself. Right, okay. And now, so we have incorporated the program. We have checked for any errors. We have assigned the machine. We have assigned the tools also. So that means it's like we are setting all the required things onto a lathe machine. So in a lathe machine, what we'll do, we'll fix the job, we'll tighten the chuck, we'll fix the tool, tighten the tool post screws, that is the bolts, okay, and then we'll go for the machining operation. So now our next step over here is going to be, we have to simulate the program that has been written. Okay, we have to check whether we are able to machine it correctly without any damages and in the proper manner. So for that, we have various options. One is we can go for entire simulation, that is just by one click of the play button, the entire the entire program will be simulated. Then there's another option where we can where the program can be simulated for every tool change. So for the first tool, unless and until the first tool is being used, the program will run. Once the usage of the first tool is over, it will stop unless and until we click once again. Yeah. So first, what we'll do is, so first onto the right side over here, we'll go here. We have set of options for zoom in, zoom out, and all those things. First, we'll give zoom limits. We'll click on that. Okay, and then we'll set our job, the workpiece, to fit to our screen. So we'll go to this top right first icon. Okay, which is the zoom icon. Okay, we'll click on that. And we'll click and drag it for the required portion so that we'll be able to see only this particular portion to be fitted onto our screen. Right? I've kept some space on left side, top, bottom, and especially the right hand side, because the tool is going to come into the screen from the right hand side, and all the machining is going to be done onto the right hand side and on the top side only. Okay, right. So we'll fit that. Okay, so here we have next motion. That means here if you use this particular motion to simulate, okay, we have to click every line. Okay, it will read only line by line. So it will read the first line, it will execute. Then unless and until you click the next time, it will not read the next line at all. So we have to click for every line for it to read and simulate. Then the next option is for next tool. So as I just told you, until tool number 1 is going to be, whose job is going to be over, till then it will run the program. So once it comes to T0202, it will stop, it will not simulate. So once the that means what? The usage of tool number 1 is over. Then we have to click once again on next tool, so that for the usage of tool number 2, whatever the program is written for in the further on will be simulated. And the last one is end of machining. So this particular option is for just a click of the button, the entire program will be simulated in one single go, right? Okay, and then after that, what we have over here, after this end of machine, after this icon, we have one adjustment bar, which is nothing but for us to show the simulation in a very fast manner or in a very slow manner. Okay, we can adjust the speed at which it has to be simulated for us to view how the simulation is going to take place. So we can adjust this particular bar. Okay. So let me select next motion. So we'll see, I'll show you all these three varieties, how it is going to operate. So first we'll select next motion. That means line by line we are going to execute. Okay, and then we will click on the play button. Okay, so we have selected next motion, that means line by line, and after that we'll click on the play button. So now what is going to happen? Yes, it has read just now over here N05 G21 G99. So it is reading this particular line. It has read that. That is G21 is for what? What is G21? Hello? What is G21?
So metric piece.
Right. So we are telling all the dimensions, what are the numbers we are using is for using SI units, that is in mm. Okay. All right, so we'll play that. So it has read that line. And G99?
So feed is in mm per revolution.
Feed in mm per revolution, right? So next, after that, we have to click on next motion. Only then it will go to the next line. Okay, right? So we have to keep clicking on this. So it has read M0, M06, T01. It has fitted the first tool. Then now it is reading N20, M03, S1500, M07. So spindle start, and spindle should rotate at 1500 RPM, and coolant is also switched on. Okay, so I'll click on next motion once again. So it is going to read the next line N25 G00 X56 Z1. That means we have told that this particular right hand side of the workpiece should be at a coordinate of Z is equal to 2. Okay, right? But we have X0 Z0 over here in this particular shape, 2 mm inside, right? So once we have given this, we have 2 mm extra material which will be making use for facing operation. Okay, so now what I have written G00 X56 Z1. So the tool will directly come over here at Z1. Z1 is going to be here at a height of 56 over here. The diameter of the material is 55. There is a 1 mm gap over here, which you can see. Right, so tool has come over there directly and is waiting for the next line to be read. So G01 X minus 1 Z1, right, F is equal to 0.2, right. So now look at this, what is going to happen for this particular line. The tool will move down vertically downwards until X is equal to -1. Yes. Okay, so 1 mm of material was removed just now. Okay, and the tool returned back to its original position, where I have given, what I've done is that, see here, I'll just play it once again. So the tool appears above the workpiece, okay, and now it is going to read the facing operation. For say facing operation, the tool has to move vertically downwards up to x minus 1. See, till there it has reached x minus 1. The very next command I have given over here is what? N35 G00 X56 Z2. I am telling the tool to go back after this, go to X56 Z2. So from here it will move in an inclined manner to a height of X56 Z2. See here. Okay, right? It has moved vertically like this. Then I'll go for next command G01. Okay, X56Z0. So I bring the tool back inside over here. Okay, and I'm ready for the facing operation where I want to remove another 1 mm of material. So I've moved the tool 1 mm inside. Yeah, and now it is going to read N45 G01 X minus 1 Z0. So it is already at the height of Z, I mean at Z0 only, but at a height of X56. So it has to come down up to minus 1. Okay, X is equal to minus 1. Okay, at a speed of F is equal to 0.2. So another 1 mm is going to be removed over here. So by the time it reaches over here, this axis is nothing but what? X0, Z0. See, this is X0, Z0 point. Okay, right? And now after facing over here, I will ask the tool to go back above. Okay, because our next step is what? Is to start the turning operation. So what we did till now is only the facing operation, and this facing operation, if you look at it, for every movement of the tool in whichever direction it has to go, it has to move down vertically, it has to move up, it has to go to the next incremental value. For everything I have to write a command. Okay, so which is called as uncanned cycle. Okay, so now next what I'm telling, G00 X56 Z1. So go back there above. Okay, now we have the workpiece material whose 2 mm of material is removed. Okay, that means the length has shortened up by 2 mm, and now onto the right side border it is exactly at 0, 0. Right, that is first thing. Second thing, any measurement of the coordinates that we are giving over here, okay, it is going to start measuring from 0, 0. Right, so both are matching. Okay, so we don't need to add uh, or make some adjustments for the exact dimensions to appear. Okay, right. Okay, so G71, so we are going to start the turning cycle U.5, give an allowance of 0.5 mm and retract the tool by 1 mm. So after it has been machined, the tool has to automatically go above by 1 mm from its current position. And then the next line of that syntax is what? G71 P65Q90, which is the starting and ending line numbers for the cyclic operation to start. Then U.1, W.1, give an allowance of 0.1 mm in both X direction as well as in Z direction. Leave that material as it is. Okay, that will be utilized for the finishing operation. In this case, finish turning. So click on X motion. Right. Now just leave it. Now until this cycle is going to be finished, this is going to show the simulation. The turning operation is going to be carried out. Right. So it is reading all the points continuously unless and until it reaches the required coordinates that we have mentioned over here. Okay, so G01, okay, X20 Z0, right? And yeah, so that means X20 will be above at a point of Z0. Till here, it is going to do the turning operation continuously. What is the next step? X20 Z minus 20. So till this next step of X20 Z20 is going to appear, it is going to do the turning operation only. See, the tool after reaching over here, it goes back, it retracts by a height of 1 mm and comes back over here from outside and starts doing the starts to remove the next layer of material. Right. So now what it is doing is, right. So now it has been almost the same shape. What we want over here, this particular shape itself is being done because we are going to all the coordinates. This coordinate from where did we take? We have written the table, right, in the last class when we wrote the program, right? So that is being used. Yeah, right. So almost this same shape has been appeared, but only thing is 0.1 mm in x direction and 0.1 mm in z direction will be left out. Okay, so if it is 20 mm, here we'll have 20.1 mm. Okay, right? Okay, P1 diameter of 20, but the diameter will be 20.1 mm or 20.2 mm, right? So next is what? M05, M09. Stop the spindle. Okay, send the tool back to its home position. So we have sent the tool back to its home position, and now it is reading the line M06 change tool. Insert the second tool T0202. Then click on next motion once again. So it reads the next line M03 S 2500. That is, start the spindle and let it rotate at 2500 RPM and M07 for coolant on. Yes, next is what? The next line is what? G70, finish turning operation. Okay, finish turning operation. Okay, and what should it do? It should do the finishing operation reading which lines? P65 to Q90. That is line number N65 to ending number N90. Okay, and let the tool travel at a speed of 0.02 mm. Okay. One second. Yes, you can see a sharp tool that is come up over here in red color, okay, which is here near this white axis line, okay, and then it is going to read that entire thing completely and it is going to trace along this path by removing 1 mm in both x and z direction. See, so once it is going to touch the tool material, the line, the color of the tool uh, will also be changed, okay, indicating that the tool is in contact with the raw material. So after this, it will go back to its return position, okay, and then it's going to home position, spindle stop, and coolant off, and end of the program, right? Okay, so after this, we have to save the program, okay, and show the simulation to the evaluator, right? Okay, based on all these things only, the marks will be awarded. Yes, any doubts still here? Yes, any doubts? Hello?
No, sir.
Right? Okay, so I'll show you the same program, but I will use making use of the next option, which is the next tool. So until the T01 job is over, we don't need to click on anything. It will just continue. It will start reading the program. So we'll go for that.
So Nikhil wants you to show the first few lines.
First few lines of the program. Huh?
Yes, sir.
Okay. Second. Yes, Nikhil, I hope now you can see onto the program editor over here, the first few lines of the program. 1 second. Yeah. Yes, Nikhil, can you see now? Right. So now here what is going to happen, T0101, and from now on, from this N15, from this line onwards, everything is going to be making use of tool number 1. So until and unless from here it changes to tool number 2, okay, when we use the next motion, or sorry, the next tool, the program is going to be read and it is going to be simulated automatically once we click on the play button. Okay, shall we continue? Right. So now here what we are going to do is that we will make use of this second icon, which is looks like a tool. Okay, we'll just go for this. One second. Okay, we have completed with this program using next motion, that is line by line. See, next tool. Okay, now we'll click on next tool. Okay, we'll use this particular option. So it is going to simulate in this by using one tool at a time completely. Okay, and we'll click on play button. So the same program is going to be read continuously. So first you saw that you did see that the phasing operation is happening 2 times, that is 1 mm and 1 mm, 2 times it has been removed. Okay, and now it is going to start the turning operation. So if there is any error in the program, okay, and then we cannot come to the simulation at all. This options will not be enabled unless and until all the errors are cleared. Please remember that. See, I have not clicked anything, only once on next tool option and click on the play button, that's all, nothing else in this case. So I've just decreased the speed. So just look here, I'll just decrease the speed over here. So which was initially playing at a faster rate, which was simulated. Here the speed was at a higher rate. Yeah. And now I've reduced it to almost half. Now look at the speed, it will be a little bit slower. You can see the tool movement much more clearly, but if I change the speed, yes, it will vary accordingly. And I'm going to make it very smaller speed. So I mean, I'm asking the system to show the simulation at a slower pace. Why we need this speed adjustment is that we want to see each and every movement of the tool, whether it is correct or is there anywhere that the tool is going to touch the workpiece, uh, I mean, without any gap, or it is going to overlap onto the workpiece. Okay, so we want to see that, or if there is a sudden impact with the tool and the workpiece, why, when is it happening? So for that sake, we have to vary the speed and check our program. Right. So almost now, what is happening? The usage of rough turning tool is over. Okay, and then it will go back to its home position. Then it will stop. It will stop. It will stop reading the program. Okay, right? Now what we have to do? Now we have to click onto this next tool option once again, so that it will start reading the second tool. Okay, and then it will start performing its operation. So see here. So once I click onto the next tool, the finish tool has appeared and it is going to do its job. There it ends the program. Right? Okay. Right. The same thing, same simulation can be showed by one click, which is called as the end of machining, where we make use of this last icon over here. Once we click it in this particular mode and then click on play button, it shows the simulation from the starting of the program till the ending of the program. Okay. So I'll select end of machining operation and click on play button. I'll reduce the speed so that you can see it much more better. So facing 1 mm is removed, then again facing another mm is removed. Now the turning operation starts. So this is the rough turning operation. So see, look at the tool. Once it is in contact with the workpiece material, it will be a different color. Once it leaves the tool, once it leaves the workpiece, that means both are not in contact. The color of the tool is going to be changed. That is how it has been indicated, where we can identify whether the tool is touching the workpiece or not at a particular moment. So only one single click to show the simulation. It is going to read the program completely and perform it. Yes. Okay. So these are the three different ways in which we can show the simulation. Is that clear? Okay. Right. Any doubts? Any doubts?
No, sir.
Right. Okay. Right. Okay. Is that clear? Yes. Have you all written the program for the, I mean, for this particular diagram? I told you about this in this particular, in the next class. I had given you that you have to write the program for this particular drawing. Have you all done it? Did you do it? Hmm? Okay, at least tell me what are the coordinates. Hmm? I'll just keep it aside. Yeah. All right. So okay. So this is what problem number 2, right? Or diagram. Okay. Right. So yes, capital O start with percentage symbol. Capital O 0202. Right. Okay. What's the billet size that we require over here? So if we need the billet size, first thing is that yeah. So point number or corners, and this is the x coordinate and z coordinate. We need this table, right? So let us see how many points are there. Okay, right. Uh, right. So point number 1 is over here, 10 mm above. Okay, 10 mm above. That means in x direction it is 10 mm. So 10. What is the z value?
0.
0. Okay. Then after that, immediately you have a radius of 5 mm. Now after this, what is the, just take this picture over here. Keep it here. Okay, so let me go here. Okay, so we have point number 1 over here, which is the color so that you can see. So point number 1 over here. Point number 2 is over here. Okay, so what is the x and z value for this? X value
15 and 5.
20.
15. Is it going to be 15?
20, sir. Yeah.
20.
Huh? How much? Hello?
20, sir.
It will be 20, and so 20 mm is the diameter. See, from 10 mm it is going to become 20 mm. 5 above, 5 below. So total length is 5 plus 10 plus 5. Total is 20 in x direction. Okay, and it is going inside by 5 mm. So z is going to be minus 5.
Minus.
Right? Yes or no? Clear? Is that clear? Right, so point number 3 will be here, so it is going to be for a diameter of 20, right, and length is how much? So here they have given 30 from here to here, plus this
minus
is 5
35.
mm, so minus 35. Point number 4, so from here it's going to go for a turn, a curved region, so point number 4 is over here, okay, whose diameter is how much? 40. Okay, distance is how much? We already have 35 plus how much is this? 10. So minus 45. Point number 5 will be here. 4 is here. So next line, next corner is 5 over here. Diameter is how much? Over here is 40. Okay, distance is how much? Already we have till here is
Minus
5 plus 30 plus 10, 45 plus another 20 minus 65. Then point number 6 is how much? Height of 50. Okay, distance is how much? 65 plus this particular value. How much is this? 10. So minus 75. Point number 7 is going to be here. Okay, so its height is 50. Okay, distance is 75 plus 15. How much is that? 90 mm. Correct?
yes, sir.
Right? Okay, so now with this table, I will start writing the program. Okay, what is the program? Okay, uh, N05. Okay, what? G21, then G99. Okay, then N10. Right? What is our next step? What is there? So we are given metric units and G21, G99, and making use of mm, right? And feed rate mm per revolutions, right? Okay, 1 second. Sorry, yeah. Okay, so where are we? Yeah, what's the next line? N0, N10. Okay, send the tool to the home portion. G28, U0, W0, right? Then N15, okay. What is there? M0, then go for tool change M06, T0101, N20, start the spindle, so M03, okay, spindle speed, okay, we'll give it as 1500 RPM, okay, start the coolant also M07. Next N25, okay, so we have set the tool change, we have inserted tool number 1, spindle has been started, we want the so here first thing we need over here is what should be the billet size. So here we already have 90 mm. We'll take another billet size of about diameter, excuse me, diameter, dia. So maximum dia is 50. So we'll make it 55. Okay, and length will be equal to 90. No, so we'll take 100 10 mm. Okay, so if that is the case, our tool should come, I'll just change the color 1 second. The axis should be here, 0, 0, axis, we want the axis to be here. So this distance is 2 mm we'll keep. That means start Z at 2. Okay, so we want the workpiece to come and land over here at 1 mm distance. What is the height that we have chosen? 55, right? So now here what we'll do is we'll go for G00. First bring the tool from a home position and place it over here. Place it over here. Okay, in this particular place where the height is 56 or 57, x-axis value, z value is 1. Okay, so x is 56 or 57 you can give. Okay, and then z value is going to be 1. Next n20. Okay, n20 G94. Okay, give G94. Yes, what is G94? Yes? Hello?
So N30.
Yeah, N30. Yeah. N30, G94. Okay, X minus 1. Okay, Z1, F. You can go for F is equal to 0.2. Okay, that means what is G94? G94. Yes, what's G94, guys? Okay, so G94 is the facing cycle. Now, if I go back to this, if you look at this program, in the initial lines, I have not used G94 at all. G01, G00, like this only for the facing operation. And I told you that it is called as the uncanned cycle. Okay, but facing operation, it's also a repetitive thing. No, we can do that. Why should I write so many lines? See, from N25 to N50, I am writing this only to remove 2 mm. Right? Okay, so there is a cycle for that also, which is having the code G94. Okay, so what we have to do is that the tool will be placed over here, and we have to make use of G94, and we have to give the ending coordinate, that is up to x is equal to -1. And then, so it is going to remove 1 mm up to this. So 1 mm will be removed. Okay, and then for this another 1 mm, again make use of G94 and give x is equal to -1, z is equal to 0. So it is going to mission in this downward direction in this particular place. Is that clear? Hello?
Yes, sir.
Yes. So same thing, x is the next line, because we have to remove 1 more mm so that the workpiece starts at x0, z0. So x -1, z is going to be 0 over here, f.2. Okay, now the facing is over. Okay, facing operation is over, right? So next what we will do is that, okay, we'll go for n is equal to n40. Next we can go for G71, that is starting off the rough turning cycle U.5. Okay, that is incremental distance. Depth of cut should be given in 0.5 mm, and after the depth of cut is over, retract by 1 mm. Okay, the tool should come back from the tool away by 1 mm. Next, N45, G71. Okay, then you're going to give P. We don't know what is the value of P. Leave it. Q, line number, starting and ending line numbers. Okay, U.1, W.1, finishing allowance in X and Y direction. F is equal to 0.2, right? So next is what? N50, right? Start writing these coordinates, right? Start writing these coordinates, right? So from here we want to start. It is going to start from here, okay? It's going to be how much? Here it is going to be, it's not going to be a straight line. It has to start from here, okay? Just a second. What have they used there? Because there are multiple ways. Okay, they'll start it from there only. All right, fine. All right. Okay, so G01 straight line, X10, Z0. Next, from there, so now the tool has arrived here in this particular place. It has to go in anti-clockwise direction. A curve has to be formed. What is the code for anti-clockwise direction? Circular motion in anti-clockwise direction. Yes? Anyone?
G03.
G03, yes. Okay. So we'll make use of G0, N55, G03, X20, Z minus 5. So it will reach here. This is Z minus 5, height is 20. Okay. Okay, so starting line number, P value is how much? 50. So we'll put that P is equal to 50 over here. G71, P50. We don't know where the cycle is going to end. Let us see. Okay. Okay, N60. Okay. So we have stopped where? Here. At point number 2. From 2 to 3, what is it? It is a straight line. What is the code for straight line? G01. Okay. X, what is the value of 0.3? 20. Z minus 35. Next, N65. Okay, from 3 to 4, it is a curved line. Yes, what is the code for that?
G02.
G02, yes, because circular motion in clockwise direction. Okay, what is the value of point number 4? Okay, point number 4 is how much? X is equal to 40, Z is equal to minus 45, right? Then N70, G0, yes, from 4 to 5, it is 1. It's a straight line, so G01, okay. X is equal to how much? 40. Z is equal to, so how much it is? So minus 45 was up to till this end. So another 20. So minus 65. Then N75, G from 5 to 6. It's a inclined line, so nothing but a straight line, straight linear motion only. So G01, okay. X is equal to 50, Z is equal to minus 75. Point number 6, X is equal to 50, Z is equal to minus 75. Okay. Next, N80, Next, from there it's a straight line, so G01, okay, X is how much? 50, Z is minus 90. So here it ends, right? That is the last point, right? Further on we don't have anything. So what is the line number? Line number is 80. So put this 80 value over here in G71, P50, Q80. Yeah, right? Now come back over here. The next line N85, N85. Okay, send the tool to home portion G28 U0 W0. Okay, N90. Okay, so spindle stop M05, M09, then N95, tool change M06. Okay, T0202, then N100. Start the spindle M03, yes, 2500. Okay, start the coolant also M07. Then N105, right? N105. Spindle has been started. Okay. Now what we can do is you can go for the finish turning cycle, that is G70. Okay, G70. Then we can go for what's the P value? P is how much? 50. Line number, starting line number, ending line number. Q is equal to 80, right? And what is the code? Is there anything else for that? Okay, at what speed rate? All right, F is equal to 0.2. Okay, yes. After this, N110, right? Send the tool to its home portion G28 U0 W0 N115. Okay, spindle stop M05. Okay, M09. Okay, and then after that, what is there? Yes, after that, the
So
last line.
0.02 is very slow now, sir.
Sorry, 0 0.0, 0.02. It's, you can give it as 0.2. Sorry. So then last one is N120 M30. That is end of program, and the next line percentage symbol. Is that clear? Right. So without this table, it's not easy to write the program. I know the codes, I prepare the table, and then I can easily write this. Right?
So could you scroll to the top, sir?
Yeah, 1 second. I'll give you the executed program
No,
only.
sir. So this percentage O0202, what is that, sir?
Yeah, this is for the this is actually for this is the syntax to start the program in the software, and always this O0202 is the program number. So program number should always start first with the alphabet and then followed by usually at least 4 digits. Can be even 2 digits also. That's the format used for the program number. Right.
So it can be any 4 digits. Sir.
Yes, it can be any 4 digit. I am just giving it as 0202 means it is program number 2. That is from the manual for the second diagram. Okay, so like that.
Okay, so O some 4-digit number.
Yes.
Also, the lab manual, could you share it with us, sir?
Yeah. I think I have posted it in the classroom.
In Google Classroom, sir.
Yeah, I think so. Anyway, I'll see. Right. There was, if it was not, there was some change that they had to do it in the manual. Probably because of that, they have not shared it. Okay,
Okay.
I'll post it. Even if it's not there, I'll post it. Okay.
Yes. Oh, yes. Thank you, sir.
Right. So 1 second, I'll give you the executed program only so that you can. Anyway, this program will also be correct. There's no doubt about that. Maybe a small change. Maybe what can be there is that this N15 M05. Sorry, what is this? M05 M09 should be here, and then G28 UW0 U0 W0 should be there probably. But apart from that, there will not be any other error that it can show because even this is also correct. Okay, right. So 1 second. Do do I have? Should have. This. Okay. 1 second. Okay, I'll make it in the same way. 05 and G28. Okay, put this here. So here also it should be the same thing. M05, the G28, U0, 05, so on. All right, fine. Okay, yeah, one more thing that we have forgotten is that, sorry, one major important thing, error will appear. So where is this G02? Where is the drawing? Here is the drawing. So G02 is what? In G03 first we have in anti-clockwise direction. What is the radius? We have not mentioned that. Radius is how much? 5. Then where is G02? That is from point 3 to 4, right? So G02, okay, x40 z minus 45 r, how much is radius? 10 mm curvature, right? And then yes, we have only these two. Okay, so yeah, yes. So just a second.
So what is the U and W, sir?
U and W is the coordinates in written in global coordinate system. So if we write x0 z0 means what will happen? It will come back over here. This is for x0 z0.
Okay, sir.
Okay, right? So if we write over
U
the
and W.
G28, go to home position, x0 z0 means there is every chance that will come back over here.
Okay, sir.
Is that clear? So to
So that is
make
the home
the
position,
system
sir.
to understand, we'll make use of a different alphabet, U and W, which is nothing but the global coordinates. Yes, what's your doubt?
That's the home position.
Okay, right. Okay, so copy down this program. Okay, I'll just make it into 2 columns if at all you need, so that you can see it much more better. Okay, 2 columns if not. and it should go up to the end. All right. Can't I do that? Yes, can you see the screen now clearly? Hello?
Yes, sir.
Yes, can you see the screen clearly?
Yes, sir.
Yes, sir.
Yes, yes, copy down this program. Copy down this program. Or completed? Okay, just answer your attendance. Niharika?
Yes, sir.
Then Nihar Venkat Sai? Nihar VS. Nihar VS is absent. Okay, Nikhil R. Nikhil R. All right. Okay, fine. With Nikhil R. Yes, he's there. Okay. Nilesh?
Yes, sir. So present, sir.
Hello? Nilesh?
Yes, sir. Present.
Okay. Nirab?
Yes, sir.
Prajwal R. Patel? Prajwal R. Prajwal? Not answering. Then Prajwal S. Bhatt?
Present, sir.
Okay, Prince?
Present, sir.
Rishabh Pandey?
Present, sir.
Rohan?
Present,
Rohan?
sir.
Roshan
Sir, Ron,
Yadav?
present.
Yes, sir.
Roshan Yadav?
Present. Present, sir.
Okay, Suman Sagar?
Present, sir.
Sagar GB?
Present, sir.
Okay. Sanjay Raghav? Sanjay?
Sir, you missed my name, sir.
Sir, Ron, present, sir.
What?
Sir, Ron, I'm present, sir.
Who?
Ron, sir, Ron.
Okay, okay. Fine. Yeah, Sanjay absent. Saranya Hiremat.
Sir, Sagar Dutt present, sir.
Who's that? Sagar Dutt Mathur, no? Yeah,
Yes, sir,
Sagar.
present, sir. You
Yes.
didn't call me.
Okay. Yeah, Sagar, yeah, you're there. Okay, fine. Okay, then
Yes, sir.
Sheikh Manan. Sheikh Manan, not there in the list. Okay. Shobit. Shobit.
Yes, sir. Present, sir.
Okay, Siddharth Shankar.
Present, sir.
Alright, then who else? Sumuk. Sumuk. Irmana Shetty Rohan. Okay, Sumuk is typing, alright. Then Subramanya Shivram Krishna. Subramanya
Present,
Shetty.
sir.
Okay, fine, alright. Okay, program is over. All of you copied the program.
Yes, sir.
Alright. Okay. So I'll just show you the simulation. Okay. Right. Yeah. So what we are doing, the same steps. Okay. So if you look over here, we'll open the software, same CNC software. open an existing part, okay, and the program that we have typed in the text, I mean in Word, not in Word document, in Notepad, because this recognizes only from Notepad, okay. So please type it in Notepad, okay. So problem number 2, I've just saved it as, okay, insert it, okay. So the program appears over here in the program editor. Right. Next thing is what? So next is what? We have to give the, save this program, give the billet size. Okay, so length, okay. So we needed about 190 was the total thing, so we can give 110 or 120. Then diameter, the maximum diameter was for 50. Okay. So here in this case, I think I've taken 52 mm, only 2 mm was the diameter, but in the program I've written it as for 55. Okay. Right. So here what you have to do is, once you write the program, remember the diameter, what you have given, what is the billet size, put that same thing over here. Okay, here you have to give 55 as per the program that I have typed. Okay, right, because here billet diameter 55, tool comes and above the workpiece is at 56, 1 mm gap. So over here we have to give 55 diameter. Start Z at 2. Okay, 2 mm we'll keep it for facing. Okay, then after that, choose a CNC machine. Okay, click on OK. Then check for any errors. Okay, check for any errors. No errors, so we can simulate it. So the next thing is to assign the tools. Same tools only for rough, because here also we have only facing, rough turning, and finish turning operations, right? So the same tools, only 2 tools we'll be using over here. Okay. So we'll select the same set of tools. For rough turning, it is going to be PCLNL R8. Okay. And for tool number 2 for finish turning, it will be PDJNL R.2. Okay. Right. So next we'll go in for save this. After you select the tool also you have to save, because if you don't save, by some chance if the software is going to shut down, or the system is going to shut down, or by any means if it is lost, so this data of what are the tools that you have selected will not be stored. Okay. Yes, we will go for, we will fit the workpiece to the screen size and let's execute it. We'll go for simulation. Okay, so here again I've gone by next motion. Yes, which one do you want, line by line or tool by tool or complete program? Hello? So first I'm simulating it by using line by line mode. Okay, so yes, it has loaded the tool, right? So G00, so look here, the tool has come and rested at Z1 above the tool diameter of the tool by having 1 mm gap. Okay, then it is going to read G94, which is facing cycle, X minus 1 Z1. X minus 1 is here below, okay, below this horizontal axis line. Okay, Z1, the tool is already at Z1. That means we are telling it to move it down vertically. Yes, so till there, and then once it is done, it is going to go back to its original position automatically. See, it will go above and rest there itself without doing anything. Okay, now the next line is also to remove facing operation for 1 mm, G94, X minus 1, Z0, okay, F is equal to 0.2 mm. Another 1 mm is removed. So now here it is the 0, comma 0. Axis is also at 0, comma 0. The workpiece is also situated at the same point. So now we can start with the rough turning E71. The cycle starts. So here I kept the simulation speed to be low. So you can see that it's first removing the material on the outside. That means on the outer diameter. So this cycle will keep repeating until it finishes all these coordinates, which is between line number 50 to 80. So step by step, it is going to remove, and that to 0.5 mm. How much have we given? U is equal to 0.5 mm. 0.5 mm every pass. Yes, now after this, it is almost completed. The tool will go back, to its home position, and spindle is going to be stopped. Tool is going to be changed. Tool change M06 P0202. Then finish turning cycle again. Then the spindle is being started M03. Spindle rotates at 2500 RPM. Coolant is switched on. Then the next line G70. We are asking do the finishing turning operation from reading lines number N50 to N80. Okay. Yes, you can see that red color tool finish turning tool appearing over here. Now coming to the closer to the workpiece and following the path. Yeah, right. So after that, the tool goes back to its home position. Okay, spindle is switched off and the end of program. Right. So after this, okay, this simulation has to be showed. So before you do this, keep saving at regular intervals. Okay. So go to D drive, create a folder using your USN number. Okay. In that, give the file name. Okay. Either you give it as P2, P3, 4, and 5, or else you give it as SeeNC1, SeeNC2, and so on. Right? Save this. Okay. This is how we are going to do it in the lab. Yes. Any doubts? Any doubts?
No, sir.
No, sir.
Clear? Okay. Is that fine?
Yes, sir.
Yes. Yeah. Right. Okay. So we'll stop here for today. Okay. Right. So
Yes, sir. Thank you, sir.
thank you.